afternoon, everybody. I'm Tony De Palma from ACCA Software. We're an Italian-based software company. We develop AEC industry software solutions, of course, focusing strongly on the OpenBIM methodology. What we'll see this afternoon, I can't go through the entire ecosystem, unfortunately. It's composed of over 35 different solutions, 15 of which are provided for free. So I invite you to onboard to the cloud.usBIM.com website, where we have the entire ecosystem of tools available. You also take advantage of 10 gigabytes of free storage, so you can upload your files. We support many closed and open file formats, including Revit. We also include the typical document file formats such as PDFs or even Office file formats, which you can all collaborate on directly in the cloud. We'll be discussing just a couple of the applications which are part of the coordination workflow inside of usBIM. And therefore, what I wanted to do is start off with an example. These are different applications that you can see on screen, part of the usBIM ecosystem, which build up your experience within the BIM collaborative workflow. It's called usBIM. Here you can start to experience the cloud-based ecosystem. It's called, as I was saying, cloud.usbim.com. So you can access that for free. What we're going to do is we're going to discover some of the core functionalities, which of course are of a great advantage to all of the different stakeholders involved in the construction workflow, therefore architects, quantity surveyors, BIM specialists or BIM managers, and so on. Just a few key features I'd like to outline, of course. When dealing with IFC, for instance, if we need to refactor a typical old version of the IFC file format, for instance a 2.3, we can realign it, we can optimize it, we can also let's say seamlessly optimize the geometry of an IFC file directly in the cloud with our application usBIM Refactor. I'll give you a quick example going through the usBIM Refactor tool. How do I start the video, by the way? Can you start the okay. So in this particular case, we're looking at an IFC 2.3 version of this viaduct, okay? And the feature here is that we can reorganize the spatial structure of the geometry, assigning new attributes, new property sets, okay, and aligning it therefore to the new structure of an IFC4, typical of an MEP system or of an infrastructure asset such as this viaduct. So as you can see here, we can build up the new hierarchy, assigning all of the different attributes accordingly, selecting the parts of the geometry that need to be refactored. So this is a very easy assignment that we can do directly in the cloud. And here we have a preview of the new structure as it has been created directly in usBIM Refactor. So this would be a typical aspect of refactorizing IFCs. What you can see now is that what would probably have been a previously defined IFC proxy, and therefore with no attributes, no property sets, has now become a fully refactored version that you can see on the right hand side. So this is one of the aspects of the BIM methodology directly in the cloud. In fact, you can see that on the left hand side we have the previous version, and on the right hand side the new version, a completely new IFC file which we can now download if necessary or keep stored within the usBIM ecosystem in cloud. Verification of models. This is also another important feature. Let's see if I can start the video. Okay. This is usBIM clash detection, another very important aspect when doing model coordination. In fact, here we can select the different geometries referring to different federated models, in this case the structural or the architectural model. Remember, we are doing this in the cloud, so we have full control over the entire collaborative workflow inside of usBIM. And here we are assigning the conditions of the clash detection by selecting the elements which are part of the structural model and the elements which are part of, for instance, the architectural model. And what happens here is it stopped? What happens here is that when we run the calculation, you can see at the bottom here we have a list of all of the interferences, which of course were defined according to certain tolerances. Okay, because we can set up if it's if we want to do a hard clash or a soft clash and so on. And we have all of the results at the bottom ready also for exporting. Okay, and we can set up this as a filter. Now, within the list of different requirements, we can therefore define what kinds of elements we want to compare in the clash detection to see if there are any overlaps, any interferences according to the classifications. Of course, you're seeing the version here in the Italian interface, but these applications are all available in English, Spanish, French, Portuguese and German too. So rest assured that whatever your language of origin, you always have the interface in your preferred language. This is just an example of setting up the filter according to the different IFC classes and therefore the elements that we want to include in the clash detection process. So as we build up the set of requirements that you can see directly in cloud, this is an IFC door compared against the windows and slabs. And what happens is once we've run the calculation, you can see it's running at the bottom, we have a visual check of these clash detections and where they are. Okay, so we can definitely link up the alert that we see at the bottom and visualize the geometry intersections and where they are present in the model. And this, of course, is very important when it comes to the coordination phase in the BIM process. I'd like to underline the fact that we are talking about an open BIM methodology, so we are concentrating mainly on open file formats, more specifically on the IFC. And here, these different issues can be tracked and assigned according to their relating discipline, whether they are, let's say, to be assigned to the structural engineer or to the architect, in order for them to be tracked down and resolved. Okay. The next case is usBIM Resolver, which sort of like connects up to the previous case study with the usBIM clash, in the sense that it allows us to therefore receive those clash detection issues and assign them to the relating specialistic discipline. So here you can see we are adding a new task. We subdivide these into tasks and topics. So we can assign them to any other collaborator which is part of the usBIM ecosystem, for instance the site manager, so we can call them into the issue resolution workflow, assigning all kinds of documentation. And here, for instance, in this particular case study, what we're doing is we're giving some indications, for instance, to the electrical systems designer or maybe to the installer, because we have noticed that there are particular errors or faults in the installation process. For instance, I can send off as an attachment to the issue in usBIM Resolver an indication that the junction box there was supposed to be positioned somewhere else. And in fact, we can therefore show him on the floor plan that in fact the junction box was to be positioned differently according to what we have in reality. So these can be selected directly on a PDF, on a CAD file. It could be the BIM model, of course. We always use the BIM model as a central point of collaborative workflows and therefore assign it for the issue management. So we have that also included inside the usBIM ecosystem. Of course, all of these can therefore be exported as BCFs, or the full report of the different issues, and managed separately if necessary. Next up, before time finishes, I wanted to show you very quickly an overview of the IDS workflow. Here we have, just before that, we have another example of coordination, of course, when we're doing comparison, and therefore when we're way ahead in the coordination phases, maybe after an issue resolution, we want to check if those modifications were in fact carried out, and therefore we have usBIM compare. So for instance, we're going to compare the two architectural models before and afterwards. We want to see what kind of changes were in fact implemented, and here the solution running the calculation engine is able to show me which elements haven't changed, which elements are missing, or which elements have been added, and you can see them visually identified directly on the BIM model, again in the cloud. So whatever kind of modifications are made, these are cross-synchronized across to all of the users that have access to the BIM model. And you can see here the visual control make sure that we have all of the capabilities of obtaining insights and useful information during this phase. I'll finish off by quickly showing you the IDS application, which is divided into two different modules. We provide one for free, which is the usBIM.IDSeditor, allowing us to create the IDS file based on our specifications, and of course the validator tool, which again, running in combination with the other, allows us to verify and check the quality of our IFC files. A quick example just to show you the capabilities of first of all creating the IDS specifications. See if this starts. Okay, so here we're in the usBIM ecosystem. What we're doing here, we're creating the IDS file from scratch according to the latest standard. I think we're updated up to version 1.0. Here we can set all of our general data, descriptions, information concerning the kind of IDS verification that we want to run on this IFC. We'll see that afterwards in the next step. So here we're filling in the essential data. Here we're setting up the IDS file with the different IFC classes that we want to check against the different types of requirements set forth by the project manager. So quality control of the IFC starts in this initial point where we use the editor. Here we can also set up some interesting attributes using the regular expression workflow. Okay, so here we can build up the structure of the different properties and classifications that we want to check within the IDS file. As you can see, when we click on the field, these are automatically filtered through and we just simply select them. Okay, then as we go into the requirements here, this is where we set up the corresponding values that need to be, for instance, respected in the IDS validation. Okay, so just completing this section of filter creation, setting up the requirements, and this sort of like covers the first phase of definition of the IDS file. The second phase that we'll see afterwards is basically loading the IDS and using it directly in the cloud again on the IFC of choice, which is probably been shared directly in usBIM, in the document management system, and upon which other collaborators are probably working on. So as we finish off creating the IDS file, okay, we also get a full report, a summary of all of the specifications. This can be sent off as a paper copy. It can be sent to collaborators through the usBIM again as a PDF also, so we can double check. And here we are in the model validation phase. I'm running out of time, but I'll try to speed it up. As we select the usBIM.IDS, you saw the menu drop down there. We have all of the applications that we are subscribed to available directly in the cloud. And here we're loading the IDS, running the specifications, and you can see that the model validation phase is covered in a very efficient manner because it's visually controlled. You can see that the elements which are not responding to the IDS specifications are highlighted with a color coding, as you can see here. We can also activate labels and therefore grab our attention on specific elements of the IFC file that may not be responding to the IDS requirements. Okay. The interesting part is that in normal cases we would have to go back to the BIM authoring solution that created the IFC. That would be a typical workflow, but because we're talking a lot about open BIM methodologies, we want to keep everything very let's say streamlined within the same ecosystem. We can also activate another tool, which is the usBIM editor, and therefore activate the editing capabilities directly on the IFC. So if necessary, I can go in and select this pole, traction pole, that was in error because it wasn't responding to the IDS specifications, and change the values, for instance, for the height of the pole, in order for it to therefore respond to the specifications set forth. We rerun the IDS verification phase directly on the model, and as you can see, at a certain point it responds now to the specifications, and therefore we can see that it satisfies the requisites, the prerequisites of the IDS file set forth. We have other possibilities here of again summarizing through labels, color coding. We can share the BCF file, or we can export in other file formats such as Excel and PDF. Thank you very much for your time, and I hope you'll join ACCA in exploring the different functionalities and tools that we have available in the usBIM ecosystem. Thank you very much.